You ever wonder how a self-driving car sees a pedestrian? Or, how your phone can just instantly pick out a face in a photo? Well, the magic behind all that is a technology called object detection. And today, we are going to pull back the curtain on one of the most powerful and popular models out there, YOLO V5. So let's dive in and figure out how we actually taught computers to see our world in real time. All right, so here's the plan. First, we'll talk about the basic challenge. How do you even get a computer to see? Then we'll get into the YOLO V5 breakthrough itself, break down its architecture, we're going to call it our AI detective, and uncover its secret sauce. After that, we'll check out the different models you can choose from, and finally, we'll talk about why any of this really, truly matters. Okay, so let's start right at the beginning. The fundamental problem, right, is teaching a machine to do something that we humans do without even thinking. We look at a scene and we don't just see a mess of pixels. We see a car, a person, a tree, and we know where they are. That's the challenge, getting a computer to do that. And that right there is what we call object detection. It's not enough for the AI to just say, hey, there's a cat in this picture. Nope. It has to say, the cat is right here, and then draw a super precise box around it. So it's really two things at once: classification, figuring out what it is, and localization, pinpointing where it is. And this is where the genius of the YOLO approach really shines. See, the old way of doing this, the two-stage method, was, well, it was slow, like turtle slow. It would first scan the image to find potential areas of interest, and then it would try to classify what was in those areas. But YOLO, and yes, that stands for You Only Look Once, it's a total game changer. It's like a rocket. It looks at the entire image just one time and predicts everything. The boxes, the classes, all at once. It's a huge, huge leap in efficiency. And that brings us right to YOLO V5. Now, this wasn't just another small update. This was a major evolution. The focus here was on making this incredibly powerful tech not only super fast and accurate, but, and this is the really key part, making it easy for actual developers to pick up and use. Just look at how fast things moved in 2020 alone. This wasn't some model that was cooked up in a secret lab for years. Oh no. This was a dynamic, constantly evolving system. I mean, we're talking about major game-changing improvements being rolled out in a matter of weeks. It was really like a living, breathing project. But maybe the biggest game changer of all was the switch to PyTorch. So older YOLO versions, they were built in this framework called Darknet. Now, Darknet was powerful for sure, but it was also super complex and written in the C programming language. That created this really high barrier to entry. But by moving to PyTorch, which is just so much more user-friendly, YOLO V5 basically threw the doors wide open. Suddenly, thousands of developers could jump in, experiment, and build their own cool stuff. Okay, so how does this thing actually work under the hood? The easiest way to wrap your head around it is to picture YOLO 5 as an AI detective. And this detective works its case in 3 clear steps. So first up is the backbone. Think of this as the detective's eyes. It's scanning the whole scene, just gathering up all the visual clues. Then you have the neck, which is like the detective's brain. It takes all those separate clues and starts connecting them, putting together the full picture. And finally, you get to the head. This is the detective's voice, pointing a finger and saying, aha, that's a car, and it's right there. But a great detective isn't just about having a process. It's about having a few clever tricks up your sleeve. And YOLO V5 has some absolutely brilliant secret sauce ingredients that are the reason it's so incredibly fast and accurate. So what exactly makes our AI detective so good at what it does? Well, let's take a look at 2 of its absolute cleverest tricks. First up, we've got something called the CSP backbone. I know, it sounds super technical, but the idea behind it is actually pretty simple. See, really deep neural networks can sometimes waste a ton of effort processing the same information again and again. So what this cross-stage partial, or CSP architecture, does is it cleverly splits the information flow. It processes one part, leaves the other part alone for a bit, and then merges them back together. The result? It drastically cuts down on the number of calculations it has to do, but without sacrificing accuracy. It's literally about working smarter, not harder. All right, another really cool innovation is called mosaic augmentation. This is a training technique. What happens is the system takes 4 totally different images and stitches them together into one big mosaic. Why do this? Well, this clever trick forces the model to learn how to find objects in really weird, unexpected contexts. And it makes it way, way better at spotting tiny little objects, which is a huge challenge in computer vision. One of the best things about YOLO 5 is that it's not a one-size-fits-all kind of deal. It's actually a whole family of models. It's like having a toolkit, so you can pick the perfect tool for whatever job you're doing, and it's always this trade-off between speed and accuracy. So let's take a look at that trade-off. We measure accuracy with something called MAP. Don't worry about the details, just know that higher is better. On one end of the spectrum, you've got the tiny nano model. It's super fast, but its accuracy score is lower. Then, on the other end, you've got this absolute beast, the X-large model. It's way more accurate, but it's also a lot bigger and slower. It really drives home the point. There's no single best model. There's just the best one for what you need. And this table just lays it all out perfectly. Just look. As you go down the list from N for nano all the way to X for extra large, you can see the number of parameters, that's basically the model size, it just skyrockets. And yeah, the accuracy, that MAP score, it steadily climbs up. But look at the processing time. It also goes way, way up. What this means is that developers get this incredible toolkit. Need something that runs lightning fast on a smartphone? Grab the Nano. Need the absolute best accuracy on a powerful server? Go for the X-Large. Okay, so let's zoom out and pull this all together. Why did YOLO 5 become such a huge deal? I mean, it's about so much more than just the technical details. It's really about the impact it's had on the real world. When you boil it all down, there are a few huge takeaways. First, it totally democratized AI. That switch to PyTorch meant that suddenly you didn't have to be this elite programmer to get your hands on it. Second, the versatility is just incredible. Having tiny models like YOLOv5 Nano meant you could put high-end AI on small things like drones or even your phone. Third, the innovations under the hood, like that CSP backbone, they didn't just make YOLO better, they pushed the entire field forward. And finally, that obsession with being user-friendly, it just accelerated everything, letting people take ideas from a research paper to a real-world app faster than ever. And all of this leaves us with a pretty fascinating question, doesn't it? We've managed to give computers this incredible ability to see and understand our world with skill and speed. So the real question isn't what can they see anymore, it's what should we teach them to look for next? What are the next big problems we're going to solve with this amazing new sense?